Hello class, in this lesson we're going to be looking at the sum and difference formulas for sine and cosine, actually and tangent as well. If I have cosine of A plus B, what is this? Well, it's certainly not this. It is not the cosine of A plus the cosine of B. This is a very common, I don't know, idea that it is because you've been taught so much about this whole idea of distribution. And you see right here a parentheses, which makes you think multiplication, which makes you think that you can distribute this out here. This is a big no-no. You cannot do this because this is not a multiplication operation here. This is a function. Cosine is a function. A plus B is the input. And this is never true, or not never, but this is not true as a general statement. So what is it? Today we're going to discover what that is. We're going to work this out. We're going to prove it, and hopefully you can understand where it comes from. Now, we're going to start off with these two circles. Two unit circles, two triangles within it. We have an angle of A and an angle of B here. So therefore we know that the angle right inside of here, this must be A minus B. And so we have the same congruent angle over on the right-hand side over here. We have a unit circle, so therefore these are all congruent to each other. And so therefore by side angle side, the two triangles are congruent. And by CP/CTC, we could say that D is congruent to D. Now we could also see from kind of a rotational geometry standpoint, if we rotate this, if we do a rotational transformation on this triangle, we bring it to this point here as well. And so we can kind of also say, because we've rotated these two triangles, they're congruent and these two sides are the same. Now what we're going to do is we're going to find expressions for D here. We're going to find another expression for D here and then compare the two. We have cosine A, sine A as the coordinate for this point, cosine B, sine B as the coordinate for this point. Over here we have, since this is angle A minus B, the coordinate of this point is cosine A minus B, sine A minus B. And then we have this other point here, 1, 0. First off, we're going to use the left unit circle. We're going to use the distance formula to write out the distance d here. So we have x1 minus x2 squared, y1 minus y2 squared. We're going to expand these. Remember our little expansion here. We have a squared. Oh, actually, let's look at the minus version. So a minus b squared is equal to a squared minus 2ab plus b squared. We're going to use that little pattern here. So as we write this out, here's the expansion of the first piece. We have cosine minus cosine squared here. That expands to this. Then we're going to expand the sine minus sine squared the same way. Now, this is where it's interesting. We have some nice things here. Notice that these two pieces here, this is 1. Cosine squared A, sine squared A, that's 1. Also, we have this over here, cosine squared B, sine squared B, that's also equal to 1. Then there's nothing we can do with the last part of it in terms of combining it. And then I'm just going to add 1 plus 1. We get this. That's the distance of this segment here. Now let's do the same using the other circle. Distance formula. In this case, this is my x minus x, my y1 minus y2, and I put it in this form. This is kind of nice here, minus 0. Let's expand this out. And now again, I have something nice. I have cosine squared of a minus b, sine squared of a minus b. That's equal to 1. So I add 1 plus 1, I get 2, and I'm left with this. Okay, so now I have the equation for D expressed over using this circle. Now, when I look at the two together, these are, the two distances that I just figured out. And notice here that, the square roots are the same. The 2 minus 2 times portion is the same. The only difference is this piece right inside here, right inside here. So those pieces actually must be the same. So we can actually say that the cosine of angle A minus angle B is equal to this expression here. That's a nice identity that we're now going to use to figure out the cosine of A plus B, the sine of A minus B, and also the sine of A plus B, as well as the tangent ones too. So from this, we're going to derive everything else. This was the hard work. Now it gets actually a little easier. Let's look at how we could find cosine of A plus B. We're going to do that by considering it as a subtraction of A minus our negative B. So now we're going to be using this as our template, and we're going to be plugging A into A, and this is the trick. We're going to be plugging negative B into B. So here we're going to put negative B into the cosine, B here, negative B over here into the sine of B here, just like this. And sometimes this is kind of confusing the first time around you see it, but look how we just kind of plug that in here. The A kind of plugs in just kind of naturally, but this minus B is kind of a little confusing the first time around, maybe. Okay, but what is cosine of negative B? Cosine of negative B is just the cosine of B itself. The sine of negative B is actually the negative of sine B, so that's where this plus sign turns into a negative sign here. And so we have this other nice identity here for the cosine of A plus B. So now we have two nice identities. Now how do we figure out the sine version of these? What can we do? So that's what we're going to look at next. Okay, to do that, we're going to start with this identity where we recall that the sine of an angle is the cosine of its complement. So to figure out sine A minus B, we're going to use this idea that, well, okay, we can say that the complement is this, pi over 2 minus the A minus B, and we're going to then rewrite it. Pi minus 2 minus A, and then plus B instead. And you'll see why we kind of want to do that in just a second. Okay, so let's start off with this. We know that sine A minus B is equal to the cosine of its complement. And I rewrote the complement in this way over here. Now I'm going to, I have an angle plus another angle. I'm going to use the angle cosine sum identity to write this out. Cosine of this, cosine minus sine, sine. Now, cosine pi over 2 minus A, actually using this identity up here, it's sine A. And sine pi over 2 minus A, using kind of the other version of this is equal to cosine of A. So this is now our other identity. I'm not going to show how we get A plus B. That's a simple exercise just like the way we did it for cosine. I'm just going to show the identities at this point. So here are the different identities. You can figure out tangent by doing some manipulations here, sine divided by cosine, and yeah, some different manipulations. But I'm not going to show that in this video. So the rest of the video is just some exercises. I'll just show the answers to this in 3, 2, 1. The nice thing about this, these sum and difference formulas, we can find the sine of 15 degrees, for example, by thinking of it as 45 minus 30, and then I'm going to use my difference formula and just plug in 45 here and 30 over here. Now I know sine 45, I know cosine 30, that's why I chose to use 45 and 30 in my equation. Over here, these are just values that come from our unit circle. Same thing with cosine, this problem here. Now, over here we expand, and according to our unit circle, we know cosine pi over 2 is 0, sine pi over 2 is 1. Solving. To solve here, let's use the identities. Let's expand these out. So I have the expansion of this here, and I have the expansion of this here. And the nice thing is two of the values are identical. They cancel away. The other two are identical as well, and this negative sign comes over here, so we have minus 2a, or minus 2 of these things. Cosine of pi over 4 is square root of 2 over 2. And we could simplify this here to sine x is equal to negative root 2 over 2. That means we have two possible choices for that. It would be 5 pi over 4 or 7 pi over 4. Okay, last one here. This is just proving the tangent sum formula, which I did not show you, but I left as an exercise. I'll show you how to do it in 3, 2, 1. So I'll just, I expressed tangent as sine over cosine, expanded out using our sine and cosine formulas that we just learned. I'm going to multiply both sides by 1 over cosine alpha, cosine beta. And when I do that, I need to distribute this times this, this times this, this times this, this times this. And so that's what I did here. And a lot of nice kind of cancellation occurs. This entire piece here turns into 1. This piece here you can see as tangent alpha. This piece here you can see as tangent beta. These cancel out. We have tangent beta here. These cancel out. We have tangent alpha here. Okay? That's it for this lesson. Have a good day, everybody.